Hello and welcome to the Flight Academy's Introduction to VNAV. My name is John Fiscus, and I'll be talking today through a rough introduction of the VNAV functionality in the Cirrus Perspective system. Now, this is going to be valid for anybody that's got a Cirrus with Perspective Avionics, no matter which generation. It's also going to be useful for my Vision Jet pilots out there. The systems work very, very similarly. So the functions and the truths that I'm talking about and how the way this thing works is going to be valid for everybody operating those aircraft. If you operate something other than those aircraft, this could still be useful information to you, but you want to make sure you get with an instructor to make sure that whatever you do in your aircraft is true. So without further ado, we're going to move into it. So vertical navigation, what it is in general, is a predictable means that allows us to descend via published altitudes on an arrival or an approach, or even user-defined altitudes, to arrive at those altitudes at specific fixes just as we get there, as the aircraft arrives there. It is also a fairly consistent way to make sure that we arrive at those fixes at those altitudes. There are a few variations, so consistent doesn't mean one single way, but it is a reliable method that has some things that it will always do every time, and we're going to talk about what those are. In general, when we're flying, we would like to stay up high as reasonably long as possible. But if we're doing an approach or an arrival or even a VFR descent with a few different fixes in between, it would be nice to manage the descent such that we arrive at our target altitude not too early and not too late. VNAV helps us do that. We can take a series of step downs. This would be an instrument approach, for example, that otherwise might be a little bit inconsistent. You know, we've got a steeper descent, shallower descent, steeper one, and then join a glide path, and we can smooth it all out. VNAV is great for that. So in this case, we've got a 5,000 foot altitude here at fix A. You'll notice I've turned it blue here, and this is because in the flight plan on your Garmin Avionics, those altitudes are going to be blue. If they are altitudes that are published as part of procedure that you're going to have to be at or above, or certainly no lower than by a certain fix, they're going to be blue in color. Fix B here has an altitude as well that's going to show up in the flight plan, and it's going to show up in white. It's not on any instrument chart. It's not on the arrival. It's not on the approach chart. But Garmin says, hey, even though this isn't a mandatory altitude, here's how high you'll be when you cross this fix. So when we cross over fix B, we'll be at approximately 4,350 feet. It's not on a chart, and it's colored white to tell us that that altitude is just FYI. You'll be crossing this fix at that altitude. Here at fix C, we can see a 3,000 foot altitude, again in blue, so that's a mandatory altitude. And our final descent prior to glide path intercept, 2,000 feet, also blue. All those are going to be those colors in the flight plan on your avionics. VNAV is going to then establish a descent angle such that we will cross at or above all of those altitudes on our way in. VNAV can vary the descent angle, but it will make sure that you are no lower than that altitude, the published blue ones, as you cross those fixes. So you're going to be safe if you stay on those VNAV altitudes. The airplane will smoothly descend instead of doing a series of chop and drops, as the old vernacular goes, and bring it all the way down to the glide path. At this point, we're going to join a glide slope or a glide path. I've got the Maltese cross here. And it's important to note that the glide path and glide slope are not the same as VNAV. VNAV and glide paths or glide slopes are different functions in the autopilot system. Make sure that you don't confuse the two, otherwise you could have a nasty surprise waiting for you when you get to the final approach fix. Here we've got a look at what I was just talking about. This is the flight plan view of a G6 Perspective Plus aircraft, and we can see blue altitudes in our VNAV locations and white as well. Again, the blue ones are mandatory. We would find those published on a chart. The white are advisory. So VNAV is a pretty useful tool if you know how to use it. In fact, I would say most instrument pilots who have now learned how to use it would say it's invaluable and has made their lives much better. And it can do that for you too. So why should you use it? Well, probably you figure this one out: smoother and more timely descents. It's really nice to have a constant steady descent rather than a series of go down, level off, not to mention the workload differences there too. One smooth descent is way easier from a workload standpoint. VNAVs associated with approaches, so if you've got step downs outside the glide slope or glide path, very handy because it's a very smooth way to hand off those step downs to a glide path or glide slope intercept. Again, VNAV and glide path or glide slope are not the same thing, but they can, the autopilot in these airplanes is capable of going from one to the other seamlessly and having it all armed in advance. Descents that are early tend to be a little bit less fuel efficient. So going down early and reducing your power and then having to power up versus one smooth steady descent is a lot more fuel efficient. We go faster up higher. You can keep your power lower the whole way in on your descent. And especially for my jet pilots, the aircraft are far more efficient up at high altitudes, fuel efficient. So you would like to stay as high as you can for as absolutely long as you possibly can. When air traffic control gives you that pilot's discretion descent, don't start down right away. Use VNAV to help you figure out when it would be the most efficient time to do so. VNAV can also be handy for weather avoidance. If ATC gives you a descent and you're not sure when to start down, most pilots err on the early side, putting themselves down lower at altitudes where they might be exposed to potentially ice or precip they would have been above otherwise, or turbulence that just gets stronger when you get closer to the terrain due to thermals or orographic activity with the wind blowing over the hills. So VNAV can help you avoid these things by waiting to descend until it's optimum to do so. But like any tool in aviation, it's not a one-stop shop. This tool is useful in many occasions, but not all occasions. And as a pilot, you're going to have to figure out when it should not be used. So let's talk about that for a moment. Unpublished procedures, pilot-generated VNAV altitudes. It's important to know that if you plug in your own VNAV altitudes, Garmin is not giving any consideration to terrain between you and that VNAV altitude. It will fly you right into a mountainside, and that violates rule number 1 of aviation, which is don't hit anything. So make sure that if you are using VNAV and you've figured out your own altitudes, you're double checking that you're not going to intersect with any terrain. This is kind of the curse that many automated pilots fly. Automation is great and it's efficient and it's smooth and it's very capable of giving us sometimes better than human level performance. But the downside of that is we get reliant on it and it robs us of our proficiency. Every now and again, leave off the VNAV. Try to do it yourself. Do a little bit of math. I'm not necessarily saying you have to do complex geometry here, but certainly try to work with your systems when the safety factor that the workload reduction would be very important to you. But if you're descending into the middle of nowhere and it's quiet, it's a nice day, do it on your own and see what tools you can use to be more involved. That'll keep your proficiency up. Weather avoidance VNAV might descend you right into the top of that cumulus cloud that if you'd only waited 30 more seconds to start your descent, just go a little further, you would have missed it and you would have had a smoother ride. Let's not forget that usually the worst icing, if it's out there, is going to be at the top of the cumulus cloud, so you could be avoiding that and a bumpy ride and all sorts of things. VNAV has no idea that stuff's out there, so weather avoidance is a pro and a con for VNAV. VNAV is also not necessarily going to give you a standard descent angle, especially on published procedures. The VNAV out, and we're going to see this when I do my second video here of us actually flying some VNAV descents. VNAV can steepen up a descent angle, and a pilot that's not prepared for it might not react accordingly or in time, and might find themselves too fast, overspeed for their drag, like flaps or landing gear in our Vision jets. Well, that's pretty fast, but certainly something that could get a person in trouble. It's not a set it and forget it. It's a set it and pay attention to it and see what changes are coming. Finally, and probably the most important thing or most common reason why VNAV doesn't work out for us is ATC. They have to allow you to go down if you're IFR. And just because you reach the top of descent doesn't necessarily mean that they're going to let you go down. It is still a handy reminder, though. If you hit your top of descent and haven't been cleared lower, you could potentially think about talking to air traffic control about it and see what they have to say. Maybe they forgot about you. More likely they have a reason that they're keeping you up high, but it's a good reminder. A couple of quick facts about VNAV. In the Piston airplanes, the propeller Cirruses, it's a default to 1.7 degree descent angle. Whatever feet per minute that's going to be, that's what they set for the descent angle. For my Vision jet pilots, 3.7 is the standard descent angle. Various procedures, as I just got done saying, can make that descent angle change drastically. VNAV will look at particularly published procedures like approaches. It will look at those altitudes from leg to leg and do whatever descent angle is necessary to hit the target. That might not be good for you in some mountainous terrain, so stay on top of it. The autopilot does, if you want it to fly the VNAV. Of course, the autopilot's not required. You could hand fly a VNAV down, but if you want the autopilot to do it and really watch the magic happen, it does require some steps. The autopilot needs to have VNAV armed via the VNAV button, and the altitude bug must be lower than your current altitude. So we have a mnemonic for that. If you're going to use VNAV, think button and bug. Vertical track will be enunciated verbally 60 seconds prior to that descent. And if you tie that as a trigger in your mind when you hear vertical track announced, you think, all right, button and bug. You look up at the scoreboard, verify VNAV is armed, look at the altitude bug, make sure it's set to the altitude that's appropriate. That'll help. Speaking of, VNAV's going to capture either the altitude bug or the VNAV altitude from the flight plan, whichever one comes first. Let's look at that a little more in depth. So where will we level off? In this case, we're looking up here. I've got an airplane at 5,420 feet with an altitude bug 5,200, and my FMS, or my flight plan, I have a VNAV altitude of 5,000 feet. Up on the scoreboard, I can see we are on VPath, and sure enough, I'm right on it. It's centered up. That's good. We're descending around 500 feet per minute to stay on it. But where will the autopilot level off? 5,000 feet, my VNAV altitude, or 5,200, my bugged altitude. Now you can get an internet point if you guessed 5,200. And Garmin's even trying to tell us that. ALTS, altitude select, is in white. That's armed to capture. It would be different, and you're about to see that difference, if it was going to capture the VNAV altitude. Here that is. In this case, we're still in VPath. You can see it up on the scoreboard in green. We're following the thing down. That's good. About the same rate. I've bugged 3,000 feet, and my VNAV altitude for this leg is 5,000. Where will the autopilot level off? Another internet point, if you guessed 5,000 feet. 5,000 comes first. We're going to stop there. And we can see in white up here, it doesn't say ALTS for altitude select, aka the bug. It says ALTV, altitude from VNAV. So VNAV altitude is going to win. And if there are other step downs after, it'll automatically do all of those step downs after that 5,000 foot. It's really nice. VNAV best practices, let's go through those a bit. If you're IFR, always make sure you're cleared for descent. This would probably go without saying, but I'm going to say it anyway. Make sure you're cleared to descend before you let VNAV take you down. If you're VFR, triple check your terrain. Rule number 1, don't hit anything. Definitely don't let VNAV make you violate rule number 1. Vertical track enunciated. We spoke about this a moment ago. When you hear that, check to make sure that VNAV is armed and your bug is set. What was the mnemonic? Button and bug when I hear vertical track. Finally, if you're cleared, well, not finally, there's a lot more. If you're cleared for the procedure and the VNAV is allowed, make sure that your bug is set to the lowest altitude. Don't set it down on those minimums. But as we saw on that last slide where we had the altitude bug at 3,000, but the VNAV altitude was 5, having the bug set at that lowest altitude will guarantee that your VNAV will do all of the step downs and not be interrupted by that bug getting in the way. A couple more best practices. Train. This video is a useful primer to go start learning how to use VNAV. Hopefully this will help make the process when you go train a little bit easier, but definitely get in that airplane with somebody who knows how this stuff works. Training center or CSIP is your best bet. Make sure, of course, that whoever it is you're flying with is comfortable with VNAV and knows how it works. CSIPs and training center instructors absolutely should. And so talk to them, go train and fly this stuff. Go practice it someplace on a nice VFR day with multiple step downs, no ATC involved, and preferably no traffic around you. If you've got to fly for 15, 20, 30 minutes to get to that place, it's absolutely worth it. Get out there, get away, and then use the VNAV and experiment with it. This is true in aviation, anytime, anywhere. Trust but verify. Always make sure, scan your scoreboard, scan the scoreboard, scan the scoreboard. How many times have you heard us say that? Us, your instructors. Well, you're going to keep hearing it. Always make sure, just like anything else, that VNAV is taking you to the place that you expect. And if I didn't make it clear enough already, this video is not a substitute for flight training. You do not get to watch this video and then say, John told me that where I was doing was fine. This is not a substitute for flight training. Go get some flight training after you watch this. There is a function that is a little bit confusing for many Cirrus pilots and Garmin pilots, I would say in general, and they come by it honestly because it's not terribly intuitive. It's a function called VNAV Direct. VNAV Direct is designed to quickly change the descent angle to meet your airplane for any number of reasons. Maybe you don't want to wait to get to the top of descent. You'd like to start your descent a little early. Top of descent still 3 minutes in your future, but you're impatient. You want to go down now. VNAV Direct will allow you to do that. Or more often than not, really, excuse me, the issue is you were held up. You weren't allowed to descend, so you had to stay high, missed the top of descent, flew right through it. 2 minutes later, now you're allowed to descent, and you'd like to use VNAV. There's a couple of ways you can go about solving this problem. VNAV Direct will change the VPath angle to meet you, but remember, it doesn't matter how steep it is. It's a computer. You said, make me a descent angle as steep or shallow as it needs to be to get me to the altitude in my flight plan when I get to that fix. And if that's descending at 1,500 feet a minute, unable to slow down with your power at idle and ripping the wings off, it will absolutely program that. So you have to still be in the process. So VNAV Direct is not an end-all solution, but it can certainly solve some problems. Here we have, or we're going to walk through a scenario where I'm going to miss it. You can see here up on the scoreboard, no VPath is armed. It's not up here in white. It would say VPath if I'd remembered to do my button and bug, but I didn't. So here we are at 5,000 feet, bugged, level, all is well. Not really. I've got a VNAV altitude of 3,500 here. The VPath is shown up here, and as you can see from this picture, just started to cross through it, but I didn't arm it. I didn't bug it. I'm not going to descend. I have a problem. the problem propagates. I am now still at 5,000 feet. I am well above now my VPath, and my scoreboard shows I still haven't pushed the button yet. So I've got a problem to solve, but I know how to solve it. Here it is. We're going to go look at this fix that we're trying to make the descent for, called Chirec, over in our flight plan. And here it is. Up on top, you can see Chirec's 4,300. The airplane has missed its top of descent. It's not even shown anymore once you fly through it. I can come down and push. You can see my finger on the soft key right underneath it. VNAV direct. When I push that button, I get something like this. Activate vertical direct 2. And that's going to be 4,300 at Chirec. Do you want to do that? Yes, I do. When I push enter, I'm going to get this. Top of descent right in front of me. Not very far in front of me. It's coming up real quick. So I better be ready. Here's what it looks like on the PFD. I've steepened the descent angle and put the VPath just above intercept. Got about 10 or 15 seconds here, so I better move promptly. But I only have 2 steps. And the 2 steps are button and bug. I need to arm VNAV, and I need to get the bug to a lower altitude. Oops. And that's all I have to do to solve that problem. Hopefully this has been some use for you. Please post in the comments below if you've got some questions, you want some follow-up, if you think another video diving in further depth on a couple of these points would be useful. Do keep an eye out. I'm going to publish a second video of me actually flying VNAV in the simulator. We've got a nice G6 Cirrus simulator that we're going to use to demonstrate some of these, and we're going to show some of the pros and cons and hidden gotchas associated with VNAV, but also demonstrate how very useful it can be. So look for that video if you want to watch it in action. Thanks for tuning in. Fly safe, and we'll see you out there.
We are the Cirrus Training Experts.